Hello students, as in the last lecture we had completed the type number 6. As I hope you all understood the type number 6, which was based on integral 1 upon sine square and cos square. Today we're gonna see a new and fresh type, that is type number 7, which is known as u into v rule, or else we can say it as integration by parts, or else we can say it as integration by parts. Or in simple language we can say it is known as u into v rule. As u into v rule, it was there in the derivative also. Here also we have u into v. In derivative we have u by v, also u divided by v, but here we don't have division rule. As before also I had explained in many videos that we don't have u by v rule, so that's why we have to do some such adjustment in a such a way that we can proceed the sum further. But in integration we have integration u into v, product of two term. So let's begin with the concept first. Let's take some few example, then you will come to know exactly that how to apply the property. So here you will have two term like this, as you can see here in the example x into cos, as here also we have x into e raised to x. Okay, so first we'll see the formula. What is the formula? It says that u into v into dx is equals to, first you will write u as it is and then integration of v into dx minus integration, then inside the box you will write d upon dx of u into integration of v into dx, then this bracket close and then dx. It means what? Now listen here. In simple language I will try to explain this. We'll consider this u as first integral and this as second integral. So you can remember this as, keep the first part as it is, then integration of the second one, then minus, then integration, then there is a bracket, then into dx. This dx, it is for this integration. Remember this dx, it is for this integration. Then inside you will write d upon dx of, that means derivative of u. Here we know that u is what? The first term. That means derivative of the first term and then integration of the second term. So you can remember the formula like this also. First, then integration of second part, then integration inside the bracket, derivative of first, then integration of second into dx. In simple language, as clearly we can see that here we are finding the integration for what? Which alphabet? For v. V is what? The second term. That means for the second term we have to find the integration. Got the point? It is on you. Write the formula 4 times. Okay, or solve the sums based on u into v. Try to by the formula. Try to keep the formula in tricky way. It is on you. Okay, so in simple language I had explained here the formula. In this way also you can keep the formula in your mind. First, then integration of second, then derivative of first, then integration of second. So in simple language we have to find the integration of the second term, that is v. Now as here in the example, as clearly we can see that here we have two term, here also we have two term. Now as we used to do in the derivative, like whenever we have two terms, we used to consider the first as u and the second as v, or vice versa, this as v or this as u. But here we cannot do like this. Directly by seeing the question you cannot say that the first one is u and the second one is v. The first one is u and second one is v. There is a proper rule and regulation which you have to follow while applying this formula u into v rule. And what is the rule here? First, we'll see the point number one. It says that functions are selected in a serial order. So here we have two functions. We have to select the function. Okay, so function, as here we have two function. Functions are selected in a serial order of letters of word LIATE. Just remember this word. Okay, LIATE. So functions are selected in a serial order. That means remember this word, that is light. You can pronounce this as light. L stand for L stand for L stand for logarithm. I stand for inverse. A stand for algebraical function. T stand for trigonometry, and E stand for exponential. Okay, so L stand for logarithm. I, I stand for inverse function, log, like log x. I stand for inverse. Inverse means what? Like this. If you have raised to minus 1, I hope you all might be knowing what do you mean by inverse function. Like sine inverse raised to minus 1, cos inverse raised to minus 1, it is known as inverse function. Algebraical means what? X, x square, that function, that term, it is known as algebraical. Trigo means what? Sine, cos, tan. And exponential means what? E raised to x, a raised to x, it is known as exponential. So according to this word, we have to select our u and v. So here first we have to check the first come first word. Like here we have x and cos. We have to select the function in serial order. Like here the first one is L, then I, then A, then T, and then E. As what is x here? This x is known as what? Algebraical function. Yes or no? This x is known as what? Algebraical function. What about this cos? The cos is known as what? Trigonometry. So first check the word in the serial order. Which alphabet come first? A come first, and then after that T follows. Okay, so A come first. So first come first, we have to consider that function as u, and the second function we have to consider as v. Got the point? We cannot take the first part directly as v, u, and second part as v, or vice versa. There is a proper rule and regulation which you have to follow. Okay, you have to select the function in this order only. Like here in the second example, x is what? Algebraical function, and E is what? Exponential. Yes or no? Exponential. So according to the letter LIATE, A come first and then E second. So first come first, we have to consider that alphabet, that function as u, and the second function as v. Got the point? In this way you have to select your u and v term, u and v function. Okay, so I hope you all understood the first rule. Now second one is what? If the integrand, that means the function integrand, contain log x or inverse trigonometric function. If integrand contain log x or inverse trigonometric function, take the first function as u, the second as v, but the second function is not given, then take it as 1. For example, you will have like this directly log x and then inverse function. So it says that the second point says that if the integrand contain a single term like log and sine inverse. So in integration we don't have direct formula for integration of log x. In derivative we have the formula for log x. Derivative of log x is 1 by x. But in integration, when you will see, we don't have the direct integral for log x. Yes or no? And direct integral for sine inverse. So whenever you come across like this integration of log x and integration of sin x, integration of sine inverse, so what you will do, simply you will multiply the term by 1, multiply by 1, consider the first part as u, and 1 you will consider as v. Here also you will consider the first part as u and the second part as v. Okay, so see to that whenever you come across integration of log x and inverse function, we don't have direct integral for log and direct integral for inverse function. So simply what you will do, you will multiply the term by 1 and you will consider the first part as u and the second part as v. That means you will consider 1 directly as v. Okay, so let's take some few examples, then only you will come to know exactly how to apply the formula and how to find the answer. Okay, now there is one more point I just want to explain. Whenever the function is a algebraical function and there is like log, cos, exponential, anything, suppose if here I take sin x, in the second example I will increase the power, in the third example I will increase the power. Okay, so here just what I just want to explain, whenever the algebraical term power increases like here x, x square and x cube, just remember this point. This is a simple trick. What is the trick? Whenever the power is 1, we have to apply u into v rule for one time, only one time. Whenever the power of x term is 2, you have to apply the u into v in that same particular sum 2 times. Whenever the power of the variable, that means algebraical term, is 2, it indicate what? You have to apply the u into v rule for 2 times. In that particular sum only 2 times we have to apply u into v. It will come. When you will solve, you will see that whenever the power is square, 2 times you have to apply u into v. Whenever the power, as the power goes on increasing, that much time you have to integrate, that much time you have to apply the u into v formula for that particular question. It's all depend on the power. As here clearly we can see that the power of x is what? Here it is 1. So only one time for this question, for this integration, we have to apply the u into v rule only one time. Okay, if the power goes on increasing, like suppose if here we have x square, for that question we have to apply the u into v rule for 2 times. So we'll take some few example on that also. You will come to know what exactly I want to explain that thing. Okay, so let's check the first example. As here clearly we can see that the first term is algebraical function and the second one is what? The trigo. So first, according to the first come first in the serial order, algebraical is first and then trigo. So we'll consider x as u and cos as v. So now let's begin. So I equals to, what is the formula? It says that first you have to write u as it is, then integration of cos, then minus, then again integration, then derivative of u, what is u over there, that is x, then integration of cos x into dx, bracket close, and then into dx. Simply what I did, I replaced the value of u by x and cos by, sorry, v by cos. That's it. Just remember the formula. Simply what I did here, I had applied the formula. I replaced the value of u, wherever you see u, by x and v by cos. That's it. Okay, now here we don't have anything like integral symbol or d upon dx. So this is without integral and d upon dx. So we'll keep the term as it is. Okay, no need of finding any answer for that. That is without integral or derivative. Okay, so now what is the integration of cos? I hope you all might be knowing the basic formulas, yes or no. So integration of cos is what? Sin x. Integration of cos is what? Sin x, yes or no. So integration of cos x into dx is what? Sin x. Then we'll keep this minus as it is. Then we'll write this integration. then box. What is the derivative of x? Derivative of x, we know that it is 1. Then integration of cos, we know that integration of cos is what? Sine, bracket close, then dx. And we know that this dx, it is for this integration, and this dx, it is for this integration. So integration cos x into dx is sin x. Okay, and then I wrote this integration dx same as it is. So let's move on to the next step, as we'll write this part same as it is. 1 into sin x is what? Sin x into dx. Okay, so here this part integral section is over, so we'll write the term as it is. Still this function is with integration, so we have to integrate this function with respect to x. So integration of sine is what? Integration of sine is what? Integration of sine is what? Minus cos x. As we know that whenever integration is removed, we always write the plus c. Yes or no? Integration is done for each and every term, so integration is removed, so at the end we have to write plus c. So x into sin x, this minus minus will be plus cos x plus c. So in this way you have to present your sum in the board exam. I hope you all understood the first example. Once again we'll see, according to the serial order of the letter, x is what? Algebraical, and cos is what? Trigo. So first come first. So according to the first come first alphabet, algebraical is first, so we'll consider algebraical term as u and trigo as v. So by add this formula, simply what I did in the next second step, I replaced the value of u by x and v by cos. So I kept this x as it is. Integration of cos is sine, derivative of x is 1, integration of cos is sine, then 1 into sine is sine. Still this function, it is inside the integral, and check how many terms are there inside the integral. That we have only one term, so directly we know that we have the integration for sin x. So what is the integration of sin x? Is minus cos. This minus minus will be plus, as integration is removed for each and every term, so we can write plus c here. Okay, so we'll take one more example, then only you will come to know. Okay, we'll take one more example here. As x is what? Algebraical function e raised to x exponential. Algebraical come first and then exponential, so u, and this will be v. So it says that what? First you will write u, then integration of v, then minus, then integration, then derivative of u, yes or no, then integration of v, bracket close, and then dx. Yes or no? Simply what I did for second example also, I replaced the value of u by x and v by e raised to x. Okay, so now the next step will be what? We'll keep this x as it is. What is the integration of e raised to x? We know that e raised to x is e raised to x only, minus integration, derivative of x is what? Derivative of x is what? Derivative of x is what? We know that 1, and derivative integration of e raised to x is what? It is e raised to x only, and we know that this dx, it is for this integral. I equals to x into e raised to x. 1 into e raised to x is what? E raised to x only, yes or no? I equals to x into e raised to x. How many terms are there inside the integral? Here we have only one term. So we know that we have direct integral for e raised to x. What is integration for e raised to x? It is e raised to x only. We had removed the integral for each and every term. We had applied the integral with respect to x for each and every term. So therefore, here we'll write plus c. If you want, you can remove this e raised to x as common. Inside the bracket, you can write as x minus 1 plus c. So in this way, you can present your sum in the board exam. I hope you all understood both the example. Yes or no? Got the point? Okay, so now we'll take one more example and we'll see what happens when the power of x increases. So now we'll increase the power of x. Now we'll see when the power of x increase. So here only just I had explained, whenever the power goes on increasing, that much time you have to apply the u into v rule for that particular question. What it means, now we'll see here. So here this part is algebraical and this is exponential. So this is u and this is u v as per the selection of the serial order of the letter. So this is algebraical and this is what? Exponential. So first come first. Algebraical is u and this is v. So I equals to u into integration of v, yes or no, minus integration, then derivative of x square into integration of e raised to x into dx and then dx, yes or no. Replace the value of u by x square and replace the value of v by e raised to x. Then now we'll keep this x square as it is, and we know that integration of e raised to x is what? It is e raised to x only, yes or no, minus then integration derivative of x square. What is the derivative of x square? We all know that derivative of x square is 2x. Then integration of e raised to x. What is integration of e raised to x? It is e raised to x. So integration of e raised to x into dx is e raised to x, and then dx, this dx it is for this part, this integral, and this dx for this integration. Okay, now focus on the next step. So here we'll keep this x square into e raised to x as it is. As here we know that 2 is a number, it is a constant, we can bring that number outside the integral as a rule. Okay, and then inside the integral we can write as x into e raised to x into dx. Okay, actually the sum it is not over. When you will focus on the second part, the section, how many terms are there inside the integral? Clearly we can see that there are two terms. So whenever we have integration of product of two terms, always and always you have to apply and see the pair also. The pairs are different. One is algebraical, second one is exponential, one is suppose one is algebraical, second one is log, one is algebraical, second one is trigo. See to that straight away you have to apply u into v rules. Okay, so here also we can clearly we can see that here the pairs are different. Whenever the pairs are different, you have to stick with the integration by part rule, that is u into v rule. Okay, so that only I had explained here. Whenever the power of algebraical goes on increasing, that much time you have to apply the integration u into v rule for that particular question. As here the power of x it was 2, so clearly we can see that here we had applied the formula of u into v one time, and here we'll apply the formula of u into v second time. So now we'll see how to apply the formula. As 2 is a constant, yes or no, 2 is a constant for both the integral, so we'll write this 2 outside the box, and then now we'll apply the formula of u into v. So it says that u into integration of e raised to x into dx, then minus, then integration, then box, derivative of x into integration of e raised to x into dx, then dx, and then bracket close. Okay, got the point? What exactly I want to explain? Whenever the power of x increases, suppose here if x square is replaced by x cube, that means 3 times the u into v rule comes for that particular question. For that particular question you have to apply 3 times u into v rule. So keep this point in your mind. Okay, so these are some small tricks, okay, which you have to remember. Okay, so this x square into e raised to x minus 2 x integration of e raised to x, just now only we had solved this part. Integration of e raised to x is e raised to x. integration derivative of x is 1, and integration of e raised to x is e raised to x, and 1 into e raised to x is what? E raised to x, yes or no? Further, x square into e raised to x minus 2 x into e raised to x. This integration of e raised to x will be e raised to x. Integration part is over, plus c. And the last step, a basic adjustment you can do if you want. Okay, so bracket open, so here you will get 2x into e raised to x minus minus plus 2 e raised to x plus c. If you want, you can see e raised to x is common here. Inside the bracket you can write as x square minus 2x plus 2 plus c. So in this way you can find your answer. So I hope you all understood all the three example, and even this third example also. As for the first and second example, the power of x was 1, so that's why for that particular question we had applied u into v only one time. As the power increases, that much time we have to apply the formula for that particular question. Okay, got the point? Okay, so let's move on to the some few more example based on u into v. Okay, and keep this point in your mind. You will bring this number outside the integral, and for the second part, whenever you will integrate u into v, see to that do that integration part inside the box only. Okay, in the bracket only you goes on solving. Got the point? Understood? Don't make this mistake. Inside the box only goes on solving, and then bracket open with this number. Okay, so let's move on to the next example. Now we'll see if what the second function, the second term is log. In the first example we saw x into cos x. Then in the second example we saw x into e raised to x, and in the third example we saw x square into e raised to x. Yes or no? In the first example it was algebraical. It was a pair of algebraical and trigo, algebraical and exponential. Now in this question we'll see algebraical and logarithm. As per the rule, as per the alphabet LIATE, log term come first and then algebraical second. So but see the pattern here, it says that first it is x and then it is log. By seeing directly, don't take the first part as u and second part as v. As per the rule, it says that we have to select the function according to this letter only. So first come first. So here logarithm is first and algebraical is second. So here first you will write log and then x. Got the point? Okay, if you interchange, what will happen? The loop of u into v, it will goes on increasing, and you will end up with getting the wrong answer. So please follow the rules whatever it says. It says that you have to select the function according to this serial order only. So in the serial order it says that logarithm come first and then algebraical second. So first come first, that means logarithm you will take u and the second part you will take v. So let's integrate. So what is the formula? U okay, u into integration of v minus integration then derivative of u into integration of x into dx, bracket close, and then dx. Simply replace the value of u by log and v by x. Okay, after this I equals to, we'll keep this log as it is. Integration of x square, here nothing is there, so we can write 1. Apply the formula of integration of x raised to n, so you will get x square upon 2 minus integration derivative of log, we know that is 1 upon x. Integration of x, just now only we had solved, that is x square upon 2, yes or no, into dx. For the point, the next step will keep this part as it is, as here 1 upon 2 is what? It is a number, it is a constant. We can bring that number outside the integral, and here clearly we can see that here 1x will get cancelled, so here we're left with x into dx. Okay, so now still the sum, it is not over, as here we have integration of x. We have to find, first check how many terms are there inside the integral. Here we have only one term, so directly we can find the answer of integration of x. Okay, so we'll keep this log x into x square upon 2 minus 1 by 2. X square integration is x square upon 2. We had integrated the terms with respect to x, so here we'll write plus c, and integration part is removed, so that's why I wrote here plus c. And the final step you can write as x square upon 2 into log x. This 1 into x square will be x square, 2 to z is 4 plus c. So in this way you can find your answer. I hope you all understood the fourth example also. Okay, I hope you all understood all the four sums, and even the rule how to apply u into v. So let's take some few more example.